Okay, the next way that we are going to solve our quadratic equations is using the quadratic formula. So if you have your quadratic equation in the form where it's in standard form, so everything on the left equal to 0, or everything on the right and the other side 0, then the solutions are in the form x is equal to, it's going to be a big old fraction. We're going to have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, a couple of things that you should note about this. A cannot be 0. You must have an x squared there. You cannot use the quadratic formula for anything higher or lower than the x squared. You must have an x squared as your highest. The quadratic formula will always work. We know that things don't always factor. We know that we can't always use the square root property. Sometimes things get icky. We have imaginary numbers, we have radicals, we have decimals. Quadratic formula doesn't care, it will get you the answer. And even better, you do not need to take out a GCF or simplify the equation before plugging into the formula. So let's try our first example and make sure that you have a calculator handy whenever you do the quadratic formula, because you're going to want it. Okay, so we have our equation, but notice that we cannot plug into the quadratic formula yet because we don't have one side equal to 0. The only way to solve a quadratic equation where you don't have a side set equal to 0 is the square root property when there's no middle term. So the first thing I'm going to do is move that 7 over. Technically, I can move the 15x squared and the 38x over, but it's not necessary because quadratic formula doesn't care if a is negative. So we have negative 15x squared plus 38x minus 7 is equal to 0. We are now in the standard form where a is equal to negative 15, b is equal to 38, and c is equal to negative 7. Remember, the quadratic formula was x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in negative 15 wherever we see an a, 38 wherever we see a b, and negative 7 wherever we see a c. There are certain things that will remain the same every single time you do the quadratic formula. Sorry, didn't give myself enough space. So if you're already writing it, it's okay. The negative in front of the b will always be there. The plus or minus square root of something squared will always be there. The minus 4 will not change, and neither will the 2. So everything in orange is going to be the same every time we plug into the quadratic formula. We just need to plug in our values now. It says the opposite of b, or the negative of b. Well, we said b was 38. Then we have plus or minus. We have another b, which was 38. We get squared. The -4 was already there, but the next thing we saw was A. We said A was -15. Don't drop your sign, the negative's still there. And then C, which was -7, all over 2 times A, which we said was -15. Let's go ahead and simplify some stuff. So the opposite of 38 is -38, plus or minus my square root all over 2 times -15 gets me -30. Now, this is where students typically have a lot of issues with their calculator. We are going to plug in that entire radicand, fancy way of saying what's under the radical, into our calculator. Do not include your square root yet. So we are going to have parentheses 38 squared. Include your parentheses around your b, because if you don't do it when it's negative, it's all going to be messed up. So just remember the parentheses. We're going to type it exactly as we see it under the radical. So -4 times -15 times the -7. And we get positive 1024. I did not take the square root yet. Okay. The only thing I did was what is under the radical. Since it's positive, it's going to remain positive. Now that we have the radical or radicand simplified to one number, let's find out what's going on with the radical. So we're going to go and we're going to take the square root of 1024 and we get a nice whole number. Since it's a nice whole number, there's not going to be a radical anymore. And we just have 32, which means that we have -38 plus or minus 32 all over -30. I'm going to rewrite that up here. So we have x is equal to -38 plus or minus 32 all over -30. If you remember when we did the square root property, whenever you had plus or minus and like terms, notice that the 38 and 32 can be combined. You're going to break it into two separate answers. Our first one will be x is equal to -38 plus 32 all over -30. And then the second will be x is equal to -38 minus 32 all over -30. And we are going to simplify these down. Okay. So if you are using a calculator like Desmos, you're going to do the division first, or sorry, the division sign first. -38 plus the 32 up top, all over -30. They want exact form, so we're going to convert back to a fraction, and we get 1/5. If you're not getting 1/5, you're using a different type of calculator. Go ahead and do the numerator first. We would have -38 plus 32, which gets us -6. -6 all over -30. So -6 divided by -30 gets us 0.2, which is the same thing as the 1/5 we found the first way. So our first answer is x equal to 1/5. Let's find our second answer. Again, if you're using the first type of calculator, you can do this all in one by pressing the division first. Negative 38 minus 32 all over negative 30. That's a crazy decimal that just keeps going. We don't want decimals, we want exact answers. So we're going for an answer of 7/3. Again, if you're not getting that when you convert from your decimal to your fraction, take the numerator first, the top. So negative 38 minus 32 gets us negative 70. Oops, forgot to switch colors. So we'd have negative 70 all over negative 30. And negative 70 divided by negative 30, convert it back to a fraction, gets us the 7/3 that we got in the first way. So remember, when you get a decimal, convert it back to a fraction. If it's asking for exact form, only give decimals when it asks for a decimal or it's talking about money. And remember, we broke this up because that negative 38 and positive 32 were like terms. We knew we could combine them.